so lesson 71 is the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So what are a, b, and c? You want your quadratic equation to be in standard form, which means the x squared piece first, the x piece second, your constant here, and equal to 0. And then you have an a b, and a c. So let's try one. Use the quadratic formula to solve. So this time my a is 2, my b is negative 5, and my c is 4. So we're in order, and we're equal to 0. So we have x equals negative from the equation, and we're substituting in a negative 5, plus or minus the square root of negative 5 squared, minus from the equation, 4 from the equation. We're going to substitute in a and then c, all over 2 times a, and a is 2. Then it's just a matter of simplifying. So x equals negative, negative goes positive. Okay, negative 5. Be careful here. You're always going to be squaring out the negative. So if it's positive or negative, we're going to end up with a positive number here. Okay, minus, and then I'm multiplying 4 times 2, which is 8, times 4, which is 32, over 2 times 2, which is 4. Okay, so now I have 5 plus or minus. 25 minus 32 gives me negative 7. Okay, I'm going to divide each piece by 4. That's the same thing as writing it all over 4. So I get 5/4 plus or minus. Anytime you have a negative under the house, we want to take that out. That would be an imaginary piece. And we get our answer. Now, every time you do the quadratic equation, what you're really finding are the solutions, roots, the x-intercepts, and the zeros. So those are all the same terms that you might see to solve. In this case, because we got an I right here, there are actually no x-intercepts. We'll talk about that more. But it actually means that your parabola never crosses the x-axis. All right, let's try another one. This time we got to get it in order. So we need to move this to the other side and this to the other side so that we have it equal to 0. And now we do our formula. X equals negative b. So if I have a negative in the equation and this is negative, let's just make it positive. Plus or minus the square root. B squared is negative 3 squared. So I'm going to go ahead and put 9. Minus 4 times a. So the number in front of x squared is actually a 1. So a is 1. Let's go ahead and label these. Okay, so I'm going to put in 1 times a times c, negative 28, all over 2 times a. Okay, a lot of errors happen here. Be careful with this. We have a negative times a negative. So I always account for how many negatives there are and then decide plus or minus. So I have 2 negatives, so I'm going to put a plus sign. And then we do 4 times 1 times, which is 112, all over 2. So x equals 3 plus or minus the square root of 121 over 2. This one turns out nice because the square root of 121 is 11 plus or minus 11 over 2. Now be careful here. You want to separate these out. This means 3 plus 11 over 2, and our another answer would be 3 minus 11 over 2. So we can go all the way to simplify this. So this would give me 14 over 2, which is 7. And this would give me negative 8 over 2, which is negative 4. Now, again, we just found the solutions, roots, zeros, and x-intercepts. One thing we could have done was actually factored this to solve. So I would have what multiplies to negative 28 and adds to negative 3. Okay, and we get 7 and negative 2. So I did just kidding, I mean 7 and negative 4, which is what we got when we did the quadratic formula. All right, so you want to take good notes on this because you're going to see this over and over again in your book, and it's the exact same problem, all right? So we're beginning with our quadratic in standard form, and we're going to derive the quadratic formula, okay? And the way we derive the quadratic formula is by completing the square, which you guys are really good at by now. So to complete the square, first thing we're going to do, plus a space, and we move the c to the other side. Okay, then we want to divide everything by whatever's in front of x. So we get x squared over a plus d over ax. Okay, so when we're completing the square, we always take half the middle number. And when we do half the middle number, we multiply the denominator by 2. So b over 2a, and we square it. So this 2 squares all three of these things. So we get b squared over 4a squared plus b squared over 4a squared. So I want to see that every time that you added that to both sides. So now we have a perfect square trinomial, okay? And this would factor to x plus b over 2a squared. I always remind you guys, too, that the half goes in the parentheses. Okay, on the right-hand side, we're going to need a common denominator. So I have an a, and I have a 4a squared. This is going to need another 4a in the numerator and in the denominator. So now I'm going to multiply this to this. We have negative 4ac, and I'm going to go ahead and put all of this over my common denominator. All right, next thing we're going to do is switch this around because I want it to look like the quadratic formula, which is b squared minus 4ac. All right, now if I'm trying to isolate x, solve for x, I would square root both sides. Okay, so the square root undoes the square, and I'm left with x plus b over 2a. And on this side, remember plus minus. We can't take the square root of this because of the minus sign here, but we can take the square root of the denominator. So if you square root 4, you get 2, and if you square root a squared, you get a. Now if I'm solving for x, I'm going to subtract this piece over to the other side. So I'm subtracting b over 2a, and I'm subtracting b over 2a from both sides of my equation. So now I just have x left on this side. And over here I have negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. It's looking a lot like the quadratic formula. Now we have a common denominator, so we're going to write it all as one fraction. And now we have exactly the quadratic formula.